Well, we started off with an exercise, quickly sketch these graphs. And as has been the pattern, people aren't practicing this sufficiently and don't necessarily understand all the rules. So we really need to review that, and that's addressed in the assignments. Because we need to be able to quickly get these graphs down so we can use them to understand other things. Not knowing what these graphs look like, not being able to sketch them instantly, is kind of like not knowing that 2 plus 2 is 4. You have certain basic things that you have to build on. You can't build arithmetic up unless you know some of the sums and multiples, you know, multiplication tables and so forth. Okay, having said that, we'll move on. The graph of 2 to the x looks like this, and we're asked to find the average rate of change of y with respect to x between the points where x equals -2 and where x equals -1, or between, well, we'll do it like that, okay? So, first we sketch the graph and we label the points: -2, 1/4, -1, 1/2, 0, 1, 1, 2, the graph kind of missed that one, and 2, 4 here. Okay, so there's a schematic at least that shows the graph. Now we're asked to calculate the average rate of change of y with respect to x between the x equals -2 and -1 point. And we're told that that means you calculate the fundamental triangle between those two graphs. You calculate the slope of the fundamental triangle between those 2 points, between the 2 graph points. So when x is -2, the graph point is 2 -1/4. When x is -1, the graph point is -1, 1/2. So that our fundamental triangle looks like this little blue thing here. We redraw that, okay, and we redraw it a little bigger because we don't have room to label much of anything on this, not only because it's close to the left edge of the board, it's too small. So we draw a bigger version. We put a little circle around this and indicate, okay, what's in that little circle now we put down here. Okay, so now we have a triangle, becomes a fundamental triangle as soon as you label the vertices. Okay, the vertices that correspond to the endpoints of the hypotenuse, to be specific. And then everything needs to go automatically. As soon as you have these coordinates, you can figure out the run. Because x goes from -2 to -1, that means the displacement from here to here, which is your run, is this x component minus this x component, -1 minus -2, which is 1. And that the rise, as we go from here to here, is this minus this, 1/2 minus 1/4, which equals 1/4. So that the slope is the rise divided by the run, 1/4 divided by 1, which is 1/4. And this is the average rate of change of y with respect to x for that interval. So this is the average. I'll use ROC for rate of change of y with respect to, I'm going to abbreviate WRTX, from x equals -2 to x equals -1. Okay, that's it. Now, just for an exercise, we calculated the rate of change between the x equals -1 and x equals 2 points. Okay, well, right here is our fundamental triangle. It's actually big enough to label, but there's a lot of other stuff here, so we pull that over here and label the points. -1, 1/2, 2, 4. Then we get the rise, which is 4 minus 1/2, which is 7/2. Now, somebody asked me, why is that? Review fractions. Not that I won't answer, I'll answer in a minute, but you have to review fractions. We can't teach you fractions in a pre-calculus course. We can't take the time to do that. There's plenty of pre-calculus to learn. You're supposed to know fractions, and I understand that fractions aren't emphasized very well in our curriculum, so you're going to need to review it. Almost everybody is. Okay, 4 is 2 halves. Minus 1 half, 2 halves, 4 is 8 halves. I'll get it, yeah, 4 is 8 halves. 8 halves minus 1 half is 7 halves. Common denominator 2, etc. But you get 7 halves. Otherwise, you say, if you subtract 1 half from 4, you get 3 1/2, and 3 1/2 is 7 halves. And you need to be able to think it through that way also. Okay, well, there's your rise. Your run is 2 minus -1. 2 minus -1 is 3. And of course, we confirm that. From -1 to 2, we got to go 1, 2, 3 units. And from 1/2 up to 4, we got to go 1, 2, 3 1/2 units. Okay. So, in any case, our slope is rise divided by run, which is 7 halves divided by 3. Now, I need to comment. Fundamental triangle is something you need to be able to do automatically. Sketching these graphs is something you need to be able to do automatically. When you're asked to do a fundamental triangle, you simply write down a triangle representative of what you're looking at, if possible. But you then label the 2 vertices, and you label the run, and you label the rise, and you divide rise by run to get the slope. Okay, now, this whole average rate of change thing, and this, of course, 7/6 is the average rate of change of y with respect to x between x equals -1 and x equals 2. You need to get used to that terminology, but you will. You know, we have a section in the book on it, and it's coming up next week, so we want to kind of anticipate that. To give you an idea of why this is important, and let me tell you that the average rate of change I would regard as the most important definition in mathematics. So we're not going to let it pass, okay? We're going to get this. If you go on to calculus, and most of you are in curricular where you need to take at least an applied calculus course, and you know, most of you are in a curriculum, aren't in a curriculum where you're going to be going into engineering calculus, which is much, much more challenging. But applied calculus is a kinder, gentler course. And it's, you know, all calculus is based on average rate of change and instantaneous rate of change. It's the most fundamental concept of calculus. And this is pre-calculus. We're preparing you for calculus. You have to understand rate of change. So, to understand it, we have a couple of other examples, okay, involving miles on an interstate, and I threw in another one. Well, I did that verbally about how many dollars per hour you're earning.